In this chapter, we're going to be looking at financial services. In this lesson, we're going to look at compound interest. Okay, everybody. So in this lesson, we're going to take a look at compound interest. Okay? So compound interest is interest that is calculated on the principal amount, and here's the key difference here to simple interest, plus any interest previously earned. So for example here, and this is a good example, if you've got $100 and you invested it at a 5% interest rate, then after 1 year you're going to get 5% of that. So we're going to add that 105 here. Now, in a simple interest account, then they would simply calculate next year the 5% of the 100 and add it on. And so they'd add on another $5. And every year they'd add on another $5, another $5 here. Now, in this case though, after this year, the interest is going to be calculated on $105. So the interest you're going to get is going to be slightly more than $5 in the next year, and then slightly more again later on. Now, with compound interest, we can also adjust the number of times that we calculate the interest over the course of the year. We call these compounding periods. So if you're going to compound it just once a year, okay, then that's being compounded annually. If you do it twice a year, let's say you do it in like December and in June, okay, we call it semi-annual. Quarterly, okay, 4 times a year. Monthly, 12 times a year. Weekly, 52 times a year. And daily would be 365 times a year. Okay. Now, what we do when we calculate that interest here, this is how the compound interest formula works. It gives you the accumulated amount. Now, the simple interest equation didn't give you the accumulated amount. It just gave you the interest. But in this case, we're going to get the accumulated amount. And we're going to get it by taking the principal amount. And that's going to mean the same thing here that it did in that lesson. It's the amount that's invested or borrowed, multiplied by 1 plus, and this means 100% of the amount, plus the interest rate divided by the number of compounding periods per year. Because what they're going to do is they're going to take that interest rate that you would get over the year, and they're going to chop it up into bits. Okay, so for example, if you're getting 10% in a year, but it's compounded semi-annually, then at the half-year mark they're going to give you 5%, and then for the remaining half of the year, you've got a little bit of extra money in there, so that you're going to calculate interest again on the back half. Okay, and it's going to be an additional 5%, but it's going to be 5% of a value that's just slightly larger than it was at the beginning of the year. So that works to your advantage if you're investing money. So again, n is the number of times it's being compounded per year, and then time would be the number of years of the investment. So what you're seeing up here in the exponent, okay, and this is the exponent here, the exponent being n times t is the number of times that you compound that interest over the term of the investment. Okay, so if, for example, if you know you're going to put it in there for, let's say, 5 years, and it's going to be compounded quarterly, well, that means it's compounded 4 times a year for 5 years. That number up there, that exponent that you're going to use there, is going to be 20. Anyway, let's take a look now at a quick comparison between compound interest and simple interest. Okay, so now remember, from simple interest, here's our equation here. And if you want to get the total, your accumulated amount, you start with the principal and then you add the interest over here. So we're going to calculate the total amount of money that you would have after you deposited $2,000 in an account that pays 5% simple interest over 3 years. So the accumulated amount is going to be your principal, which in this case is $2,000, plus $2,000 multiplied by the interest rate multiplied by 3. Okay, and when we put that all together, we're going to get $2,300. Now, let's compare that to a compound account here. So same situation here, but what we're going to do here is we're going to invest $2,000, and it's going to pay 5% per year compounded annually, and we're going to leave it in there for 3 years. The only difference here is this is going to be compounded. So the accumulated amount is going to be the principal, so it's still $2,000, 1 plus... Okay, well, the interest rate is still that 5% there. So we're going to put that in as 0.05. Because it's compounded annually, you would simply divide this by 1. And then the exponent is going to be 1 times the number of years. So we're going to put that up to just to the 3 there. And when you evaluate that, you are going to get, when you plug that into your calculator, you'll get $2,315.25. And so now notice that it is slightly larger. And that's because every time you add the interest to the account, the next time you calculate the interest, it's going to be calculated on a slightly larger value. And so, yeah, now that's not a huge difference over 3 years. But if you can leave that money in that account for substantially longer than that, that difference grows and grows and grows. So this question tells us to calculate the final value of a deposit of $700 invested at 4% per annum compounded annually for 5 years. Okay, so our accumulated amount will be the principal, $700, multiplied by 1 plus 0.04, okay, because I'm going to convert that to a percent, to a decimal. That divided by 1. It's compounded annually, so divided by 1. So to the exponent 1 multiplied by the number of years, 1 times 5. And then again, once we just plug this into the calculator, and when we do, we are going to get $851.66. Okay, pretty good return. All right, now this question says, calculate the amount of interest earned on a deposit of $1,500 invested at 2% per annum, compounded annually. Now, we're going to assume in this case that it's just for 1 year. We're just going to take a look at the growth in 1 year. It doesn't say that specifically, but that will be our goal here. Now, the compound interest equation includes the interest, and so if we want to get the interest, in this case I have to subtract the principal, so which is different than the simple interest equation. The simple interest equation, I had to then calculate the interest and then calculate then add the principal to it. Here, to get the interest, I got to take the principal away. So to get the interest, I got to take the accumulated amount and subtract the principal. So in this case, it's $1,500 multiplied by 1 plus 0.02. Now it's compounded annually, so over 1. And we're just going to have this to the 1 minus 1,500, the principal amount. So this will give me the growth, and then I take away where I started, and it turns out I end up with $30. So I would have earned $30 in interest that first year. Okay, so for this question we read, it tells us to calculate the final value of a deposit of $3,000 invested at 4.2% per annum for 5 years, but this time we're going to start to change the compounding. So our accumulated amount here will be $3,000 multiplied by 1 plus, now we're going to change the compounding here. So first of all, I'm going to write this as 0.042. But if I'm going to compound it semi-annual, I'm going to divide by 2. Then I'm going to put a 2 up here in the exponent, multiplied by, and then 5 years. Okay, so it's going to be to the power of 10 there. And when I evaluate that, I will get $3,692.99. So basically $3,693. Now, watch what happens when I do this monthly, when I increase the number of times we compound it. So the accumulated amount is still 3,000, still 1 plus 0.042, but now what I'm going to do is I'm going to divide by 12, because we're doing this monthly. Then this is going to be the power of 12, and again multiplied by 5, the number of years. So it's 12 times a year for 5 years. When I enter that into my calculator, I am going to get $3,699.68. Now, again, notice that's not a huge difference. But if I had a larger investment and I left it in there for a larger amount of time, then again these two would start to stray away from each other more significantly as time went on. Okay, the growth with compound interest is quite fascinating. So in this question we read, calculate the final value of a deposit of $1,400 invested at 3% per annum for 2 years with the following compounding periods. Now we're going to do it a little bit more often. So our accumulated amount here will be $1,400 multiplied by 1 plus, here's our rate as a decimal, 0.03, but this time we're dividing by 52 because there are 52 weeks in a year. And so up here we'll take it to the exponent of 52 multiplied by 2 for the 2 years that it's in there. And when we plug that into our calculator, we are going to get 1,486.55. Okay? So it's a little bit of growth. Now, what happens if I back off and we just do it monthly? So 1400 multiplied by 1 plus 0.03, this time divided by 12, and then to the 12 multiplied by 2. And when we do that, we get $1,486.46. Okay, so the difference between those two, not that big. Not that big. But bear in mind that we're still talking about a relatively small amount of money, really, and for a relatively small amount of time. Okay? That difference, like I've been implying here, gets more and more significant. What increases that value there is going to be the length of time that it's in there. Okay, because that number of compounding periods, that exponent is huge. So not only the amount of time that's in there, but right down here, okay, the number of compounding periods per year, that's going to make a big difference as well. So the more compounding periods you can get and the longer you can leave the money in there, the better in terms of the growth of that account. This question says, calculate the amount of interest earned on a deposit of $6,000 invested at 1.9% per annum, compounded quarterly over 5 years. Well, there's not really much that's all that different here, except for the fact that we haven't really talked about a quarterly investment. So it'll be 1 plus, again, turn that into a percent. Quarterly means I'm going to divide by 4 and raise that to the 4 multiplied by 5, because I have it in there for 5 years. Okay? Oh, and we are looking for the amount of interest. So what we're going to do here, I probably should have done it like this. I'll go back and change this. The interest we're going to look for will be the accumulated amount minus the principal. Okay? So accumulated amount minus the principal. And when I do that, we see that we earned $596.47. All right, so just for a moment here, we're going to talk about something called the Rule of 72. And if you go and talk to somebody at the bank here, you might hear them use this just to give people a sense of how quickly their money grows here. So if you're investing your money and it's compounded annually, okay, that's important, there is an easy way to estimate the length of time it'll take to double your investment. We call it the Rule of 72. And so what you do here is the number of years to double your investment is going to be 72 divided by the interest rate as a percent. Okay, don't convert it to a decimal, leave it as a percentage here. Now, this isn't exact, but it's a pretty good approximation, okay? So just to give you an idea here, how long does it take for an investment of $3,000 at a rate of 5% compounded annually to double in value? Well, the Rule of 72 says that I would simply take 72, divide it by 5. Now, the answer here is 14.4, so we're just going to say approximately 14 years. And what's really neat about this, everybody, is that, let's look at this next question here. It says, what if you invested $7,000 at a rate of 5% per annum compounded annually? Well, see, the neat thing about the Rule of 72 is it doesn't really matter what the investment is. It doesn't matter how much money you're investing. What matters is the interest rate. And so here, once again, 72 over 5 is equal to 14.4, which is approximately 14 years, a little bit more than 14 years. It doesn't matter how much money you invest. Okay, the doubling time is related to the interest rate. All right, so for this question here, we're going to use the Rule of 72. So use the Rule of 72 to estimate how long it would take the following investments to double. So once again, not interested in the amount of money. In fact, in all of these questions, I can kind of ignore that principle that they're giving me. 4% compounded annually is going to be 72 divided by 4, and that is going to give us 18 years. 9%, 72 divided by 9 is going to give us 8 years to double. 2.35%, so 72 divided by 2.35. Okay, well that's a lower interest rate, so things are going to go up here. This is going to end up taking us about 31 years to double. And then I've got another one here on this other side here. Okay. Again, that $1,500, not relevant here. 0.8%. Well, 72 divided by 0.8 that is going to give us 90 years to double. Okay? So again, the issue is really just the interest rate as long as it's compounded annually. All right, hi everybody. So this one says, look up the TD Everyday Savings Account interest rate. I did. It's 0.010%. The question is, how long will it take to double an investment of $500 at that rate? And again, that's not the relevant part. The relevant part is this bit of information right here. And if we take 72 and divide it by 0.010, okay, we are going to get 7,200 years. Okay, well, it's going to take a little while in that savings account to double your money. All right, now this last question we want to look at is a slightly different take on this. If you wanted to double your money in 15 years, at what rate of interest would you need to invest your money? Well, if we want to double it, okay, we know that it's going to be normally 72 divided by the interest rate. So let's call R here. And that equals the number of years. Well, in this case, we know the number of years. We want it to be 15. So what I would do typically is I would multiply, okay, treat this as if it's 15 over 1. I would cross multiply. 72 is equal to 15 times R. And then to get the 15 by itself, I would divide. So 72 divided by 15 would equal my rate. And in that case, I'm getting 4.8%. So as long as I can get an interest rate of about 4.8%, I should be able to roughly double my money in 15 years.